A real login form is broken right now, on a real project. A user types the correct password. They hit submit, nothing happens. No error message, no spinner, no clue. Just a button that sits there, doing absolutely nothing. Watch what happens when an AI agent opens this exact file, reads the real error sitting in the editor's problems panel, and rewrites the broken function without me typing a single line of code myself. No searching Stack Overflow, no guessing which function is at fault. This is Claude Code, running directly inside Visual Studio Code. Not a browser tab, not a separate app you have to Alt-tab into. Inside the editor you probably already have open right now, on the machine sitting in front of you. By the time this is done, you'll know exactly how to set this up from zero, how to use it on a real bug in a real project, and one mistake that quietly leaks people's private files if they skip a single setting. So stay with me, because that mistake shows up in the middle of this, and it's the kind of thing most tutorials never mention, even the paid ones. Here's why this actually works, and why it's genuinely different from the autocomplete tools you've probably already tried and gotten tired of. Most AI coding tools finish your sentence. They guess the next few characters based on whatever's sitting around your cursor. That's useful for typing faster, sure, but it's shallow. It has no idea what the rest of your project looks like. This tool works the opposite way. You describe what you want in plain language, and it reads across your whole project, not just the file you happen to have open. It sees your error logs, it sees your file structure, it sees the actual warnings your editor is already flagging in the background. It even understands how your files reference each other, so a bug in one place doesn't get treated like an isolated problem. Then it proposes a change, shows you a diff with the old code in red and the new code in green, and waits for your approval before touching your disk. Nothing gets silently rewritten behind your back while you're not looking. That single detail, reviewable diffs before anything is saved, is why professional teams trust this on real production code, not just small toy projects nobody depends on. Before we go further, if this is useful so far, drop a like and leave a comment with the editor you use most, because it genuinely tells me what to build the next tutorial around. Let's set this up from a completely empty machine, assuming you've never touched this before. First, open Visual Studio Code. Press Ctrl-Shift-X on Windows or Linux on a Mac to open the Extensions panel. Type Claude Code into the search bar at the top. The official listing is published by Anthropic, and it bundles its own copy of the command line tool inside it, so you don't need to install anything separately just to get started. Click Install and give it a few seconds to finish downloading. Once it's done, open any file inside your project folder, not just the folder itself sitting in the sidebar. This part matters more than people expect. The panel needs an actual file open to activate properly. Now look at the top right corner of your editor. You'll see a small spark icon appear right next to your usual editor controls. Click it, or use the shortcut Command Escape on a Mac, Control Escape on Windows or Linux, and the panel opens instantly either way. A chat panel slides open on the side of your editor, right where you'd expect a normal sidebar to sit. Sign in with your account when prompted, wait a couple of seconds for the connection to confirm, and you're fully set up. That's the entire installation. No terminal commands required, no configuration files to hand edit before your first message. Now for the real test, on the actual broken project I mentioned at the start. Back to that login form. I open the file with the submit button logic, the same file where the bug is actually living. In the chat panel, I type one plain sentence. The password field validates correctly, but clicking submit does nothing, and there's a warning sitting in the problems panel on this file. That's the entire prompt. No code, no technical jargon, just a plain description of what the user's experiencing. Within seconds, the agent reads the file, reads the diagnostic warning sitting in the editor's problems tab, and traces the actual issue. An async function that was never awaited, so the click handler returns before the validation check even finishes running. That's the kind of bug that can eat an entire afternoon if you're scanning code line by line, because nothing about it throws a visible error. It proposes a fix. A diff panel opens showing exactly what's changing, line by line. Red for what's removed, green for what's added. I read through it, confirm it matches the actual cause, and click Accept. The button works. No console errors, no guessing, no 40 minutes lost to random forum threads that half apply to your situation. One more thing worth knowing while we're still inside a real file, type the @ symbol inside the chat box, and you can reference any file or folder in your project by name without leaving the panel. Fuzzy matching works too, so typing something close to the actual file name is usually enough to find it. This means you can point the agent at 3 or 4 related files in a single message, and it reads through all of them before responding, instead of guessing based on just the one file you happen to have open. On larger projects, this alone saves you from copy-pasting code snippets back and forth just to give the agent enough context.
Now here's the warning I mentioned earlier, and this is the part I'd actually pause and re-watch if I were you. By default, this agent can read any file it needs to in your project folder in order to understand context. That includes a file most developers keep sitting right in their root directory, the one holding API keys, database passwords, and secret tokens, usually named something like .env. If you open that file, or even just leave it accessible in a project the agent is actively working in, there's a real chance sensitive values get pulled into context without you ever noticing it happened. It doesn't announce itself. It doesn't ask permission first. It just reads whatever it can see. The fix takes about 10 seconds, and it's permanent once you set it. Inside the chat panel, you can add a permission rule that denies read access to that specific file for every session going forward on that project. Do this once, right after your first install, before you ever open a real project that has live credentials sitting in it. It's the single most skipped step in every setup guide out there, and it's the one that actually matters the most. Let's go one level deeper now, because typing full instructions from scratch every single session gets repetitive fast, and repetitive isn't how anyone actually likes to work. Type the command /init inside the chat panel. This scans your entire project and generates a file called claude.md, sitting quietly at the root of your folder, right alongside your other project files. Think of it as a memory file for the agent. It records your coding conventions, your folder structure, which testing framework you use, which package manager you prefer, even naming patterns you tend to follow. Every future session reads this file automatically at the start, so you stop re-explaining the same project rules over and over, message after message. On a real project I maintain regularly, this cut my average prompt length by more than half, simply because the agent already understood the conventions before I typed a single word. It's a small step that pays off every single day after you take it. Let's build something new with all of this now in place, using the same login project from before. The task? Add basic rate limiting, so the same IP address can't hammer the login endpoint 50 times in a minute, which is exactly the kind of thing attackers try first. I open the relevant API route file, and I type the goal in plain language again. Limit login attempts to 5 per minute per IP address, and return a clear error message once that limit is hit.
The agent proposes new code, a small counter stored in memory, checked right before the login logic runs, plus the error response itself. The diff appears, same as before. I read through the red and green lines, confirm the logic actually matches what I asked for, and accept it. Now, here's a detail almost nobody talks about, and it changes how confidently you can experiment. Every accepted change creates a checkpoint automatically. If a later change breaks something down the line, you can rewind to any previous checkpoint and undo it cleanly, without touching your project's actual version control history at all. It's a safety net sitting underneath a second safety net. That's what makes it comfortable to move fast without the fear of wrecking something you can't easily get back. A quick habit that separates people who use this well from people who constantly fight with it. Keep your relevant files open as you go. Don't bury them in unopened tabs. The agent reads live diagnostics from whatever's currently open in your editor. So if there's a TypeScript error or a linting warning sitting on screen, it already knows about it before you even describe the problem out loud. Open the file with the issue first, then describe the symptom, not your guess at the fix. Let the agent trace the actual cause on its own. More often than not, the real bug is sitting somewhere you weren't even looking, in a file you hadn't opened yet. If you've made it this far, here's the golden habit worth carrying with you.